welcome back. Jake Simons here once again, and today we're talking about a part of the engineer design process that is so important that I feel like gets neglected quite a bit. I see a lot of teams, they jump right into practices, and the first thing they want to do is start building. Build, and that is a mistake. So you could see with the BelleBots, we've documented this with videos, that we spent a lot of the first two practices really understanding the rules. And once the girls understood the rules thoroughly, inside and out, going through the student-friendly appendix, going through different scoring examples, even simulating scoring examples on the field with the ball and with labels, we then came up with strategies. We know how the scoring works now, so we came up with different strategies to see how many points we can score. Once we understand the rules and once we've come up with strategies, we then let those strategies guide our design. Now, we don't want to design the entire robot right now. We want to design certain subsystems of that robot. So we're starting with the base subsystem, the drivetrain, the part of the robot that makes the robot move. And as I noticed the girls sketching out and labeling their designs of the drivetrains, I noticed that they had 4 wheels. That's great. I noticed that they had 2 bi-beams connecting the wheels. That's great. But they were forgetting about, because of their inexperience, some pretty important parts. And so I wrangled up some of the Rising Phoenix students, Beckett in particular, who's a very experienced builder in our program. And he decided that he was going to build 2 prototypes, one side of a drivetrain that uses gears and another side of the drivetrain that uses chain and sprockets. And he explained those 2 different types to the girls. And then we re-recorded and had them add things to their designs. We want to design before we start building. And all 5 girls came up with different designs. And after those 5 girls, what we're going to do, after their 5 different designs, we're going to pick and choose which one we think is the best, based on pros and cons, based on ease for them, based on what we want to accomplish with our strategies. And then we can start building. Take a watch.
So, do you all remember when you were driving and you were shooting the balls? Do you remember how you had to line up right here on the field to score? All of that would be impossible if you didn't have the drivetrain. So can you all see how there's these wheels here? So when those wheels turn, they allow you to move across the field. So then you can score or you can pick up balls. And that's kind of the base of our robot, because if you can't move, you can't pick up balls and then you can't shoot. So without a drivetrain, you can't really do anything. So you can see that I have motors here, and those motors will spin the wheels, and when the wheels spin, it will move the robot across the field. But there's a couple different ways to do this. So you can see these are 2 different types of drivetrains. So drivetrains are basically this base of the robot, and you can see that this one has a chain, and this is called a chain and sprocket drivetrain. And what happens is the motor attaches here, and when it spins, it moves the wheels with it. So you can see that because this is spinning too. So you can imagine if a motor's on this, it would spin this forward. But you can also use gears. So can you, if you see this black gear, when it touches this blue gear, it makes it spin. So if you have a motor on this one, it can cause this to spin. So basically, the 2 different ways you can do this is you can use chains or you can use gears. But each one is better for different things. So this one, with gears, it's a little less friction, which means it spins easy. So it'll be better for like higher speeds, which will allow you to move around the field faster. But this one is really easy to build because it's just one chain going across all the wheels, which can allow you to do it really easily. Another thing that's different is you can see that this one, if I put these side by side, you can see that this one's a little wider, and that's because the sprockets take up more space than just the gears, because the gears are thinner and don't take up that much space.
Why are there 2 of those?
So those are the motors, and that's what's going to be spinning. So if you remember, if I spin this one, it makes the if I spin this gear, it makes the wheel spin. And these are what are actually spinning. So when that motor is connected to this cable, it allows these wheels to turn, which allows you to move around. And if you remember from when we were driving, how if you moved one of the joysticks forward, one of the sides would go forward, and when you moved the other one forward, the other side would go forward. That's kind of what it's doing, because do you remember how if you went both forward, the whole robot would go forward? So that's kind of what, because you have two different sides, you can move forward with both of them, or you could go backwards with one of them, and that would allow you to turn. B?
Why do you have two types of wheels?
So for this one, this is a little bit of a more complex robot, but you can see these wheels, these are called omni wheels. So if you see, they have almost more wheels in them, and if you look at this, they can go side to side like this, right? So this will allow you to kind of spin really easily. But what this other wheel does, you can see how it doesn't have those other wheels, so it doesn't slide side to side. And that just lets you do better turns, which are more precise.
Beatrice, what are you working on right now?
I'm working on the drivetrain, and I'm working on labels on my drivetrain.
Okay. So Beatrice, are you building your drivetrain right now, or what are you doing?
I'm designing it.
You're designing it. We have to design before we build. All right, Nora, talk about your drivetrain design here.
I added gears, so this wheel moves at the same time as that one. And I added motors so the whole robot can move.
Okay. Sorry, go ahead. I was just going to say, so how many of your wheels, out of all four of them, how many are moving at the same time? One of them, two of them, three of them, or all four of them?
All four of them.
So that would make this drivetrain four-wheel drive, right? Nice. All right, Brooklyn, so you're designing your robot, your drivetrain, not your whole robot, your drivetrain here. And tell me what you decided to go with.
I didn't add any chains,
Sprockets, yeah. That's a tricky one.
or gears.
Yep.
I only added motors.
Okay, so you have two motors on there, I see. And how many wheels, since you don't have any chains and sprockets, and since you don't have any gears, how many wheels are going to be spinning based on your motor? Two, only two. So it's two-wheel drive, right? So we'll have to decide whether we want a two-wheel drive or four-wheel drive robot. Nice job. Can you explain your drivetrain design here?
So I'm making some connected parts. Instead of like showing like from straight down, I'm kind of doing the sides.
Okay. And you have, what are the numbers there? The 1, 2, 3, 4.
They're the wheels.
All right, Katie, talk about your design.
So I just finished my design, and I have 1, 2, 4 wheels, and
are your wheels just kind of hanging out by themselves?
no, and like they're connected because it's the bottom of the robot, but it's called the drivetrain.